Hello everyone, good day. Welcome to the HCL Technologies session at Citrix Converge 2021. Hope you are enjoying all the session of Citrix Converge. I am Abhishek Chaudhary, Enterprise Architect of Digital Workplace Practice at HCL Technologies. With me I have Shiv Kishan Suthar, who is a Solution Architect of Digital Workplace Practice at HCL Technologies Limited. And today we are going to talk about how you can reduce latency of VDI by leveraging Citrix SD-WAN and leveraging Azure Virtual Desktop RDP Shortest Path technology. In today's session, we are going to speak about how the workforce typically looks like post-pandemic, poor network, a typical problem in any VDI environment, and how we are going to resolve it. We are going to discuss about the architecture of the solution to resolve the poor network problem. Next, we are going to show you how we have configured the RDP Shortest Path in the session host of Azure Virtual Desktop. And next, we'll walk through our lab components and we'll show you what we have configured in our lab. And at last, we are going to show you the demo of the solution. So over to you, Shiv. Let's take it forward.
Thanks, Abhishek. In this session, I'm really excited to discuss about what is happening in post-pandemic to workforce and poor network, which is typical problem in any VDI environment. Latency. Now, let me tell you all that latency plays a big role in user experience and performance of today's digital workplace. As we all know now that in post-pandemic, in most of organizations, workforce are working from home. We have seen these four trends: remote and hybrid workers. Post-pandemic is going forward, almost 75% of workforce will work from home. Remote locations 5 days a week by 2025. Elastic workforce. Most of the business are going digital and the need of remote workforce will dynamically increase or decrease by 50%. BYOD. The concept of BYOD, bring your own device, is increasing exponentially as more organizations are offering work from home like facilities. We have seen a decade of transformations happen in pandemic. For last but not the least, and security and compliance. When such a volume of people adopted it, where we have seen need of security and compliance is increasing every day as organizations are more prone to cyber attack these days. I would like to draw your attentions on poor network performance. This is a typical everyday problem of many remote worker environment. Over the last 20 years, the number of recommendations to resolve network experience problem has been get more bandwidth. The fact is that despite bandwidth is increasing by several order of magnitude, a poor user experience remains the number one complaint. The word has brought the marketing message that more bandwidth is faster and the faster is clearly better than slower. To more specific here, common belief is that 100 Mbps is faster than 50 Mbps and will clearly deliver a better user experience. Is this true? No. Let's understand it in better way. A car comes to fork in the road as both left and side right directions are signed to airport. If the left fork is 70 miles per hour, 8 lanes freeway and the right fork is 30 miles per hour, single line shared road, should the car go to left or right? If speed is the criteria for selections, then the left fork for freeway is clearly over 2 times faster. However, if distance is added into the equations, this choice may change. For example, if the left sign shows to airport 35 miles and the right shows to airport 10 miles, the time assessment is shorter for the right fork. The airport is 30 minutes journey via freeway versus a 20 minutes journey via single line road. Does the car per hour rate of the road directly related to the experience? No, it does not. The time to destination, on the other hand, defines a material parameter for driver's choice. As with the PC, arriving sooner is faster than arriving later. Or, put in experience terms, arriving later can lead to miss a flight, which is not a good experience. Latency time define one of the most important aspects of packet delivery. Interestingly, now network time, which is known as latency, is well defined, but unlike the bandwidth is seldom considered or referenced. Latency is a measure of time taken for a packet to travel to destination and back, round trip time RTT, and is expressed in milliseconds. Elevating the importance of latency and bandwidth as a capacity, not a speed, will significantly improve the end user experience. Now, hope all you have understood that how latency is important for us. In our solutions, we have tried to solve this problem for Azure Virtual Desktop, also known as AVD. Let's see how we can reduce the latency by leveraging the SD-WAN device with Azure Virtual Desktop. Now, next Avishek will discuss more about the solutions and take you through the architecture and demo of the solutions. Thanking you all.
Thanks, Shiv. So let's see what is there in the architecture of today's solution. The solution will try to address the latency issue of the Azure Virtual Desktop users. So I have divided the architecture of the solution in 3 parts for the easy explanation. In the first part, I am going to take you through the overall architecture of the solution. In the second part, I am going to talk about the architecture of the SD-WAN appliances and devices which have the digital network architecture of the SD-WAN master controller node and the home office users. And in the third part of the solution, I am going to speak about the architecture of the RDP shortest path. So now let's see the overall architecture of the solution. Before I explain you the architecture of the solution, I must tell you why we have chosen Citrix SD-WAN. Actually, Citrix SD-WAN connect branch offices or home offices directly to Azure. It provides a secure, reliable connection. It provides maximum uptime and productivity through highly available connectivity. It lowers in cost compared to ExpressRoute and Azure Premium VPN gateways. It provides deep visibility into the traffic, including the RDP, SDX, Microsoft Office 365, and proactively address any network issues that arises. For Azure Virtual Desktop users, it also provides granular prioritization of the RDP traffic. In our solution, we have deployed Citrix SD-WAN appliance as a virtual instance in Microsoft Azure to avoid complexities and cost associated with the Azure Express Route or point-to-site VPN. With Citrix SD-WAN 110 devices deployed in the home user's location, it is easy to establish secure, reliable connections between home office and Azure VNets where Azure Virtual Desktop resides. In the architecture diagram, you can see that in the upside box, which is a pictorial representation of Azure, we have deployed the SD-WAN MC and VM and the AVD session host. The Azure VNet is extended to the home office users, and one of them is located in the Puerto Rico, and other user is located in Noida in India. Both the users are using the SDWAN 110 devices for the connectivity. Also, RDP Shortest Path is configured in the Azure Virtual Desktop Session Host VM. And since there is no NSG or Azure or any third-party firewall is in place between the user endpoint, so the user can easily able to establish a direct UDP-based transport between the remote desktop client and AVD session host. RDP uses this transport to deliver remote desktop and remote app while offering better reliability, consistent latency. The green line of the traffic actually shows the direct connectivity between the remote desktop client and session host. Direct connectivity reduces the dependency on the Azure Virtual Desktop gateways. It improves the connection reliability and reduces latency. In the absence of SDWAN, the endpoints directly connect to Azure public gateways and traffic passes through the red line, which is a pictorial representation of the TCP-based communication. I hope you get an idea of the overall architecture of the solution. So let's focus on how we have configured the SDWAN appliances and devices. So I'm going to explain you now about the SDWAN. In this diagram, you can see in the left side top contains the details of the SDWAN master controller node appliance, which is actually a Linux-based VM, which is located in Azure. It has got 3 network cards associated with it, which serve for different purposes. This master controller node or MCN can help in creating direct connections from every location to Azure. It also ensures an always-on connection. It extends the secure perimeter network to the Azure. It also evolved to be a simple, easy-to-manage branch network. A public IP address is assigned to the WAN-facing interface of the WAN NIC card, and another public IP address is assigned to the management interface of the management NIC card to access the management interface in Azure. We have assigned management NIC card with the management subnet of the network or Azure VNet. The NIC card marked for LAN has been associated with the LAN subnet of the Azure VNet. The NIC card marked for WAN is associated with the WAN network subnet of the VNet. The license assigned to this MCN appliance is a buy OL license, that is bring your own license model. We have applied the license through the licensing tab in the device management console. The top right side of the box of the slide represents the LAN subnet, where all the Azure Virtual Desktop session host will reside. The down left side box represents the home office of the Puerto Rico user who is connecting his endpoint, which is a MacBook, to the LAN interface of the SDWAN 110 device deployed at his home. On the other side of the box, on the down right hand side, it represents the India-based user who is connecting his endpoint, which is a Windows laptop, to the Wi-Fi interface of the SDWAN. The user will get an IP address from the predefined Wi-Fi subnet or the LAN subnet of the SDWAN. We have also defined routes in the Azure, which will help in connectivity, which I will show you in the lab walkthrough. I hope you will now got a fair idea of the SDWAN architecture. So let's move into the RDP Shortest Path architecture, which I'm going to show you now. As I have mentioned you earlier, RDP Shortest Path is a feature of Azure Virtual Desktop that establishes a direct UDP-based transport between the remote desktop client and session host. RDP Shortest Path transport is based on a top highly efficient universal rate control protocol, which is called URCP. URCP enhances the UDP traffic with active monitoring of the network conditions and provide fair and full link utilization. URCP operates at low delay and loss levels as needed by remote desktops. The removal of additional relay reduces the round trip time, which improves user experience for the latency sensitive applications. UDP Pro 3390 is used in this transport. RDP Short Path uses a TLS connection between the client and the session host. Now let us see in the slide diagram how the traffic flows. So first, the session host sends the list of its private and public IP4 and IP6 addresses to the client or in our case the endpoints. The client starts the background thread to establish a parallel UDP-based transport directly to one of the session host IP address. In step 3, while the client is probing the provided IP address, it continues the initial connection establishment over the reverse connect transport to ensure no delay in user connection. If the client has a direct line of sight and the firewall configurations are correct, the client set up a secure TLS connection with the session host. After establishing the short path transport, RDP moves all dynamic virtual channels, including the remote graphics input and device redirectives, to the new transport. If a firewall or network topology prevents the client from establishing direct UDP connectivity, RDP continues with the reverse connect transport, which is the TCP-based transport. Now let us see how we can configure the RDP shortest path in the session host VM in our next slide. So here, this is basically can be done just in 2 steps. In the first step, we need to configure 2 registry keys in the Windows. This enables UDP to be used for RDP. I have done that with the help of PowerShell, as you can see in the screen. Now I ran 2 PowerShell scripts here, you can see here. In the next slide, you can see that I have run another PowerShell script which basically configure the Windows Defender firewall on the session host. This will allow the port number 3389, which is a UDP port, for the UDP connection, and you can see in the screen. And that's all. Your session host is ready for the UDP shortest path traffic. So as you can see, I have got my Azure portal open. I have got a virtual machine here. This is the SDWAN appliance. So I have followed the naming convention for this VM. So in this VM, actually, there are 3 nickers. So if I go to the networking tab here, I can find out. So this is the nicker which I have told you. This is for the management part of this VM. So it is having one public IP address, one private IP address, which we are using for the management. The second nicker is for the LAN. So it is only having a private IP address. And here we have enabled the accelerated networking. And this one is for WAN. So this NIC card is for WAN, and it is also having a public IP address and a private IP address. And accelerated networking has been enabled in this one as well. So we have actually enabled the accelerated networking in all the 3 NIC cards. So I have already discussed about this architecture with you already. So this is our VM, and let's see the disk of this VM. So it is a customized SDD. It is having 120 GB of the disk size, and the size of the VM is this D3V2 VM, standard D3V2. And if you go to the overview of this VM, you'll see that this VM is having a Linux operating system. And we are going to connect this VM from the Citrix Cloud, and from Citrix Cloud we can able to view the details of this appliance. So let's go to the Citrix Cloud and see how it works. Okay, currently I am in the Citrix Cloud console. I am going to SDWAN Orchestrator. I'm clicking on Manage. So this is the all side. As you can see, I've got, this is my MCN node. It is in US, and this is I myself. I'm currently in Noida, and this is the another device which is currently in Puerto Rico. So this device is currently shut down, and that's why it is showing red. So it is not connected right now. However, this line is showing green because this device is currently online. The other person, it is in night in US, so he's probably sleeping right now. So let me see to the reports, and let me go to the
So as you see, this quality, I have got two connection was I've got one BSNL, which is BSNL broadband, and you can see the line is dropping. This connection is not consistent connection, so it is clearly showing here that this line is dropping. It is not consistent, so it is dropping. So the matrix is very good. However, my Geo is always up. It never dropped a single packet. So this is how you can see. So I hope you understand how to do a troubleshooting, how it's helping, how good it is. So now I am in the Azure RDP Shortest Path VM. This is the Azure Virtual Desktop VM, and let's quickly go to the networking tab. So here you can see this is in the part of same network, which is the SDWAN VNet LAN subnet, and the IP address of this VM is 10.2.1.5. And also you can see like this VM is having the latest Windows Enterprise version, which is a single session dedicated host, and it is having the 20s2 EVD, that is latest Windows version, Windows 10 version here. And the size of this VM is standard B2S. So since we are using it only for testing, we have kept it as standard B2S VM, which is having a 4 GB of memory and 2 vCPU. Disk size is again 127 GB of disk, you can see here. So that's all about this VM, where we have already configured the RDP shortest path requirement with the help of PowerShell script, which I have already shown you earlier.
Okay, so that's all about the lab infrastructure. Now let's move for the demo. So now I'm going to show you a demo of RDP shortest path. I'm using a laptop from India. I'm currently in Noida. I'm trying to connect from Noida. So as you can see here, so here I have the remote desktop client, which is the Azure Virtual Desktop client, and I'm double clicking on it. So here I have a workspace, and this is my BSNL fiber network, which is the broadband network at my home. So the workspace name is RDP Shortest Path. I just double clicked on that. It is connecting to the RDP Shortest Path workspace. It is asking for my credentials. I'm using my demo lab credentials here for the login. My demo lab domain name is libraspacedemo.com, and it is connecting to the Azure Virtual Desktop. Okay, I'm inside the VM, so I will try to find the experience monitor. So I'll click on the experience monitor, as you can see here. So it is showing that I am having a slow connection, and it is connecting through TCP, and round trip time is 250 milliseconds, so which is actually high. So I wanted to confirm whether it is the same VM or not. I'm typing the host name, and yes, this is the same VM which I'm connecting. So this VM has been configured for RDP shortest path, but since I am not using SD-WAN, I am using BSNL fiber, so it is taking the TCP route. Okay, now I am going to change my network, and I am going to connect to the SD-WAN. Now I am going to the same workspace, RDP shortest path, as you can see here, and it's connecting to the RDP shortest path. It is asking for my credentials once again. Let me type the credentials. Okay, it's connecting. I am in the RDP shortest path VM, and I click on the experience monitor, so I can see UDP is enabled right now since I am using SD-WAN. So as you can see, transport protocol is showing UDP, and round trip time is 200 milliseconds. So it is reduced by almost 50 milliseconds. Although it is complaining about the issues like round trip time is very high, but still it has reduced by at least 50 milliseconds, as you can see here when I have connected with SD-WAN. That's actually good. So again I wanted to verify whether I am connected to the same host. I'm going to the command prompt and typing the host name. Yes, correct, I'm in the same host. So you can see, like, when it connected to SD-WAN, it directly used the UDP path for the connectivity and it logged in. So now I'm going to show you another demo for a user who is currently residing in Puerto Rico. So I am connecting from a MacBook Pro in Puerto Rico. I'm using the Azure Virtual Desktop Mac Lite, providing my credentials to log in on the Mac client, the same workspace. So I just logged into the VM and let's go to the connection, show connection metrics. Okay, it is showing 102 milliseconds as the round trip time. So I am going to check whether this is the same VM which I have configured for the RDP shortest path. So I type the host name. Yeah, it is the same VM. So I'm going to sign out now. Currently I'm using the Wi-Fi of my home network, so I'm just going to switch off the Wi-Fi and switch to the LAN connection. So my LAN connection, actually the SD-WAN connection. So it is going to connect to the SD-WAN LAN subnet, this particular MacBook. So yeah, now it is connected to the SD-WAN LAN subnet. So I am going to connect to the RDP shortest path workspace once again. I'm going to type my credentials and let's wait for a few seconds. Okay, cool. So I have currently logged into the VM. So let's go and check the connections. So connection metrics. Okay, great. It is showing 54 milliseconds, which is almost half, right? So I think let's check once again whether we are in the correct host or not. Just type the host name in the command prompt. Yes, we are in the correct host. So actually SD-WAN is working, RDP shortest path is working. Please note, RDP shortest path is currently not certified by Microsoft for the AVD macOS client. However, it works fine in our demo. So that's all. With that, I would call today a wrap. I wish you all a great Converge. I hope you have attended all the sessions and have gained a lot of knowledge. Once again, thank you very much. Bye-bye.